So, good evening, everyone. So, in our last videos, we started a new course called Data Structures and Algorithms with Python. The timings of this class is from 8 p.m. to 9 p.m. Monday to Friday, every day these classes will be there. The duration of this course is 2 to 3 months. Fees for this batch is nothing but rupees 999. You will get running notes and videos. And the contact number is nothing but this one. Okay, if you want to get registered for this course, you have to contact to this number. The email id is nothing but this one. If you want, you can communicate with them. And I explained in the first video itself the complete syllabus what we are going to discuss. In that already we started introduction to data structures and algorithms, and even some programming exercises also we started. If you see, I defined what is mean by algorithm. Example for calculating addition of three numbers, how to write algorithm, and what is mean by flowchart, and how you can able to implement the given problem. Next, and after that, what are the advantages of algorithm or flowchart, and what properties we have to follow. And even we covered one program. Okay, so what is that program? First program we discussed, so program to read a string and convert all even indexed values into uppercase. And what is the second example program that we have covered? Same program I repeated for odd indexed values, sir. And what is the third program that we covered? Sum of all the elements present in the list. Next, what is the fourth program that we covered? Write a program to find maximum of two numbers. These things we covered in our last video. Sir, even in addition to that, I explained some different cases like how to insert a node at the beginning of single linked list, how to insert a node at the ending of single linked list. And anyway, today we are going to see how to traverse or how to display a single linked list, sir. First, I will talk about this traversing one by one. Let us have a look once. First, I will explain the diagrammatic explanation for this. Have a look once. Consider I have a single linked list is there like this. I told what is the structure of single linked list in the last video. This is nothing but a node structure, sir. A node will be there in this format. Like, consider in my single linked list, I have some 5 nodes are there. Okay, some 5 nodes are there in my single linked list. Okay, sir, you know very well the last node is always pointing to null, or in our Python we will call it as none. And these nodes are nothing but something like this we have. And compulsory there is a link is existed between one node to another node. So any node next field is pointing to the next node except last one, because for 15th node we don't have any continuity. And sir, in this entire linked list, we have one special node will be there, always pointing to the first node in our linked list. Sir, I think the name of this node already I have given. Anyone remembered what is the name of this node? Do you have any idea? Yes,
Self
please.
node.
Very good. It is not a self node. It is nothing but head node, which is always pointing at the heading, sir, which is always pointing at the initial node. Sir, now I want to traverse. So traverse or display function I want to implement. Display means what? I want to display each and every element present in this linked list. Sir, what I am going to do is, so we should not change this head. I will make the first node as temporary node. I will write code parallelly so that you can understand well. Right. Sir, def display, that's all. Sir, first what we have to do, I am going to check. Okay, I am going to take, so temp is equal to self dot head. So first node is there, right? That I am assigning to temp. So if your temp is equal to none, that means if there is no temp means what we have to print? Sir, I can print. So my single linked list is empty. My single linked list is empty. Okay. Then we can return. Simply it is going to return. Suppose if my single linked list is there, then what we have to do? I think once if you write return, no need to take else. Sir, if it is not there, what we have to do? I'm going to take a while loop. While if your temp dot next field is not equal to none, that means is its next field is not there? No, it is there. Then we have to print. So temp dot data. We have to print temp dot data and transfer the control like temp is equal to temp dot next. Sir, is this data is available? Yes. Print that data 11. Now break this link and ask your temp to point to the next node. Since it is a while loop, again it will check. Sir, is temp dot next is not equal to none? Its next field is not equal to none. Then so print this data and remove this link. Ask your temp to point to the temp tends to next. Sir, is it next field is none? No. Then print the data and transfer the control to next node. 14. Now temp tends to next is not equal to none. So print the data. What is the data? Sir, 14. Now transfer. Sir, temp tends to next term is not equal to none. No, next is none. Then what we have to do? Sir, have you observed? Is it possible to get this data? No. That's why what I will do is temp is not equal to none. Sir, is this field is available? Yes, it is available. So it will print the data. It will print the data 15. Next, temp tends to next. That means temp will pointing to none. Sir, is temp is not equal to none? No, temp is equal to none. Then it will come out from this. Have you observed how beautifully implemented this display function? Just to display the elements present in the single linked list, we have to write code in this style, sir. So don't go in detail into this. Just at a top level, how this function is working, you people got some ideas. Can you please confirm? Is it clear up to this?
Yes, sir, it's clear.
Yeah, in the single linked list, I will explain in detail. Don't worry at all. Okay, just at the top level, try to understand. Yes, please respond everyone. Clear up to this?
Yes, sir.
Right. Okay, fine. Next. Better I will copy paste this code. Right. Sir, next, already we completed these 4 programs. Let us do continuation of this. So 5th program. Sir, what is my 5th program here we have? Sir, I want to find out. Okay. I want to find out my 5th program is nothing but I want to find out, sir, maximum, no, minimum of 2 numbers. I want to implement a program to find minimum of 2 numbers. Sir, easy code only, right? No need to go in detail into this. Okay. So only few modifications I will do. Sir, in the place of max, I want to replace with min. In the place of max, I want to replace with min. So here also min. So here also min. So here also min. So here also min. And here also min. Okay, here also we have to take a min, and even here also minimum. Okay, here also minimum. So minimum, so minimum, so minimum, 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 minimum. But we need to change the algorithm, right? First one by using predefined functions, no problem. Second one, in the place of greater than, you have to take less than. So here also in the place of greater than, you have to take less than. In the lambda functions also, we have to take less than. And here also min function is directly available. I will run this code and I will check really whether it is working properly or not. We have to cross check. Now py space test dot py. Sir, it is waiting for two numbers. Let us consider 10 and then 20. Minimum value is nothing but a 10. Suppose if I am giving 10 minus 20, minimum value is nothing but a 20. Like how you can able to calculate minimum of two numbers by using this small piece of code, I think you people got very clear clarity, sir. Of course, easy code only. No need to think too much on this. Can you please confirm, is it clear up to this?
Yes, sir.
Yes, sir.
Right. Now, sir, we will go with some theory part, then again we will come back to this. Sir, in the theory, somewhere I covered properties of algorithm. Now my requirement is, I want to talk a few minutes about, sir, complexities. Okay. So what is mean by complexity? What is mean by complexity? Sir, complexity means what? Sir, very simple. How your algorithm is going to work, that we can able to calculate by using this complexity. Sir, complexity of an algorithm is the amount of time. Okay, is, so the amount of time, okay, or space required by the algorithm, okay, or by the program, or by the algorithm, okay, by algorithm or program, okay, to process the inputs and to produce outputs. So how much amount of time and how much amount of space, okay, it is required to execute a particular program or to execute a particular task, we can call it as complexity. Sir, how many types of complexities are there? With respect to time, we can measure, which will become time complexity. So with amount of space also we can calculate, which will comes under space complexity. But generally we won't concentrate in detail on space, because nowadays, powerful virtual machines are there in programming language. They will take care of deallocating the resources. Sir, what is mean by time complexity? Time complexity is nothing but the amount of time, the amount of time taken, the amount of time taken by the algorithm to process the inputs, sir, is called as time complexity, sir, which is measured by using, sir, t of that particular algorithm, otherwise t of n, time complexity of n. Sir, what about the space complexity? What about the space complexity? Sir, the amount of space taken by the algorithm to process, okay, to process the inputs is called as, sir, space complexity. So which is measured by using s of n, space complexity of that particular input n. So how you are going to check which algorithm is best means by using this space and time complexities, sir. Sir, can you please confirm, do you have any doubts up to this? Do you have any doubts up to this? Please confirm. The basic idea I provided, beyond that nothing. Everyone please respond. Right. Sir, I have a doubt. I have a doubt. Sir, how to measure these time and space complexities? Suppose if I want to travel, okay, I want to purchase petrol for my bike. I will calculate the distance in the form of kilometers. I will calculate the mileage of my bike by using kilometers. Sir, if I am giving one liter petrol, sir, it is going to reach 45 kilometers. Okay, like that, I'm going to represent the measurements. Even if you have a mobile, we will measure space. So how much space it is going to occupy? What is the RAM size? Like that, for everything, we have a measurement. Similarly, how to measure these complexities? Sir, do you know, for this some asymptotic notations are there? Okay, asymptotic notations are there. Sir, how you can able to calculate this? Sir, for this we have some special symbols are there that we will discuss in detail in our upcoming classes. But for your understanding purpose, I'm telling the first one is nothing but big O notation is there. Okay, big O notation is there, which is always represented of, so capital O of something like N or something like this. Okay, big O of N. Sir, similarly, we have another function is there called omega, omega notation, omega notation. Of course, here I can't able to type. That's why, sir, omega I am representing in the form of W, W of N. Then we have, sir, theta notation is also there. Theta notation is also there. Sir, it is also not possible to represent. That's why I'm going to represent theta of N like this. Okay. So otherwise I will represent this theta as 0, 0. Then it will be good. Okay. Sir, how to represent the notation? By using these formulas. Omega notation, theta notation, big O notation. Of course, it is related to the mathematics. In upcoming classes, I will explain this. If I explain now, you people are going to get bored, sir. Okay. Now my requirement is, sir, how you can able to analyze? How you can able to analyze? Sir, all these algorithms, okay, all the programs or algorithms are classified into three types. Three types. What is the first one is nothing but, you know, worst case complexity. Worst case complexity. We will give highest priority to this. Second one is nothing but what? Average case complexity, average case complexity. Okay, so next third one is what? Sir, best case complexity, best case complexity. Like all these complexities are divided into these categories, but we will give high importance to worst case. Okay, because even you can see in our general words also, if any person is taking some amount, so you will ask, are within how many days you are going to return? Sir, he is going to tell 2 days or 3 days. Okay, consider worst case 1 week. Within 1 week you have to return. Have you observed worst case means what? Dead end, dead end. Worst case, last case. Okay, so that is nothing but the final. So best case means what? For example, I will take one simple algorithm. Okay, I will take simple algorithm. Sir, you are going to reserve for movie tickets. You are going to reserve for movie tickets. Sir, there are some rows will be there, right, in the movie tickets. Sir, you told to your friend, Are, sir, I passed row, third row, fourth row. And of course, we have some rows also there here. Yeah, guys, can you please confirm? Am I audible?
Yes, sir. Now we are audible. Little bit disturbance is there.
Yeah, now is it okay?
Yeah, sir. It's fine.
Yes, sir.
Right, good. Maybe some network issue. Sorry. Now, observe carefully. Sir, uh, of course, these 4 seats are nothing but, assume these 4 rows are nothing but VIP rows. Sir, I asked my friend, Are, I need 3 tickets. I need 3 tickets. Can you please reserve for me in this VIP block? He told, Sir, I will check. So all possibilities I will try to check. And then he returned 3 tickets for me. He returned 3 tickets for me. Sir, if those 3 tickets are available in the first row, it is nothing but a best case. It is nothing but a best case. Suppose if these 3 tickets are available in the last row, sir, it is nothing but a worst case. If these 3 tickets are available in these 2 rows, I can say it is nothing but average. Okay, no problem. Have you observed? So luckiest person will get tickets in this. Unluckiest person will get tickets like this. Of course, 50% remaining seats. Have you observed? Like we are going to calculate. But remember, in our this entire data structures and algorithm course, whatever time complexities we are taking, it will be always worst case time complexities. Okay, so keep this in mind. Then, sir, how you can able to calculate these things? Sir, do you know big O? Always we will go for big O notation. Big O of if you are taking one, it is nothing but I can say constant time, sir. If I take big O of n, it is nothing but something like linear time is required. Linear time is required. Okay. Suppose if I am taking big O of, so I can take n or log n. Sir, it requires logarithmic time. Okay. Logarithmic time. Okay, so big O of, sir, even we have n log n time, n log n time. Sir, it is also logarithmic time. Sir, then you can calculate a big O of n square, n square. Sir, it is nothing but something like a quadratic time. Okay, sir, even you can calculate big O of 2 power n. Sir, it is nothing but, do you know, exponential time. Okay, so even you can calculate n factorial. Sir, it comes under factorial time. Like this, we can measure time complexities in any one of these form based on your algorithms. Beyond that, nothing. Of course, today we will see at least one or two examples to calculate these time complexities, sir. Sir, can you please confirm, is the theory part related to this complexity, how to measure these complexities, what are the different cases are there? Is it clear for you people, friends? Please confirm.
Yes, sir.
Yeah, sir.
Yes, sir.
Sir, your voice is disturbing, sir. Please use chat window for communication. Next, sir, I will take some two examples for calculating these time complexities. Observe carefully. Observe carefully. Sir, in this example, I am going to take one function, def, some function I am taking, which is taking some n value. Okay. Sir, here I will print array boss for n is equal to 100. For n is equal to 100. So number of instructions in big O of n. Big O of n. How many instructions are there in this I want to print? Okay, sir, I will call this function by passing 100 as an argument. How much time it is going to take, I need to calculate. Sir, now I am going to write n value we have passed, right? N time we need to execute. Sir, I am going to take count is equal to 0. Count is equal to 0. Then, so I is equal to 0 while the value of I is less than n. Okay, so here I will take count is equal to count plus 1 and I is equal to I plus 1. Then at last I want to return the value of count. A simple algorithm, sir. A simple algorithm. How it is going to work? Boss, suppose if I am giving n value as a 5, so it is taking count is equal to 0. Count is equal to 0. First time your I value is 0, it is less than 5. It is less than 5. Count will be incremented by 1 in. That means the loop is executed one time. Then I will become I plus 1, 1. Is it less than 5? Yes, condition true. Sir, again 2 times got executed. So I will become 2. 2 less than 5, condition true. Sir, 3 times got executed. 3 less than 5, condition got a true. 4 times executed. 4 less than 5, condition got executed. 5 times executed. Sir, 5 less than 5, condition got a fail. The loop stopped. So when n is equal to 5, how many times it executed? 5 times. When n is equal to 100, how many times it will execute? 100. So here I have to get a count as 100, sir. So really whether we are getting that value or not, we will cross check. Now let us run the program. Let us run the program. Have you observed? For n is equal to 100, the number of instructions, okay, the number of So instructions, how much time it is going to take is nothing but big O of n. So here n is equal to 100 means 100 times this code got executed. Okay, 100 times this code got executed. Sir, it comes under what is the complexity of this algorithm? So the complexity of this algorithm we can measure. Okay, so complexity. Yes, what will be the complexity for this? I will measure in terms of time, sir, time complexity. So is nothing but a big O of n, big O of n. Okay, sir, got it clear for this first algorithm? Please confirm. I request everyone to please respond. Clear up to this?
Sir, this time complexity means nothing but number of iterations, right?
Yes, that's all. We are not required to measure other complexities. Aman Agarwal. So in deep algorithms, I will explain about other measurements. Okay. As of now, it is not required because the worst case, if n value is 100, compulsory, it has to execute 100 times. When you are talking about searching and all these things, then we can measure. For example, assume I want to sort the 10 numbers. Then best case means what? If already those 10 numbers are in sorting order, then we are the best case. We are in the best case. Okay. So then almost time complexity will be ignorable. Suppose if 50%, 5 numbers are in ascending order, remaining 5 numbers are not in ascending order, then what will happen? It is nothing but average case. So now I want to sort all the numbers in ascending order, but the input data is in descending order. Worst case, we have to do maximum comparisons. Are you getting? So that we will discuss for all the algorithms, not for these basics. Now, second one. Sir, I want to talk about
Sir?
complexity. Yes.
Sir, I have a silly doubt.
Hmm.
So you have taken big O, na, sir. How come to know we have to take big O or theta?
That I will explain, madam. That I will explain.
Oh,
There is
sure,
in detail
sure.
explanation will be there. I will explain.
Sure, sir.
There are
Thank you,
some
sir.
functions are there. If it is in that area, then it will comes under big O. You can represent in any form, no problem at all. But regularly we are going to use this big O. Okay.
Okay, sir. Sure.
Right. Second algorithm, sir, I want to calculate for n square. N square. That means what? It has to execute how many times? Double time. Double time. Sir, I will write one more loop inside this. I will write one more loop inside this. Okay. So here I am taking j is equal to 0. J is equal to 0. Then, sir, while your j value is also less than n, I will count c is equal to c plus 1 and j is equal to j plus 1 and I is equal to I plus 1. Sir, now observe how many times it is going to execute. Have you observed? If n is 100, 100 square, have you observed? So 10,000 times. This is nothing but I can say it is nothing but, sir, which type of equation it is? Which type of equation it is? Quadratic time it is going to take. Quadratic time it is going to take. So wherever if you are getting within a loop, another loop is there means, so its notation is nothing but a big O of n square. Okay, sir, majority of the times all sorting algorithms will have time complexity as big O of n square. All sorting algorithms, you can take any sorting algorithm, because why? One loop will be there. For example, for loop 1 will be there. So again we have to take one more for loop. Sir, this for loop is going to select the first element, and this for loop is going to compare that first element with remaining all the elements. If you want to just have a look once, one small example. So I want to show you. So time complexity for sorting algorithms. Okay, for sorting techniques. Sir, now let us see. Is it going to give all the time complexities for all sorting? Have you observed? For selection sort, sir, big O of n square. For a bubble sort, big O of n square. For insertion sort, big O of n square. For quick sort, okay, sir, big O of n square. For bucket sort, big O of n square. Sir, for cell sort, big O of n square. For tree sort, big O of n square. Majority of algorithms will have big O of n square. Sir, which is going to reduce the complexity? N log n. Have you observed heap sort is the best? Sir, merge sort is the best. Have you observed? And even count sort is the best. Radix sort is the best. Tim sort is the best. Sir, cube sort is the best. Like that, we have to decide. So when compared with big O of n square, whatever I told remaining things, those will comes under best cases, sir. Okay, I mean best algorithms. So you can able to see best case algorithms are represented with omega notation. Average case so are represented with the help of theta notation. Worst case are represented by using big O. You can ignore space complexity, sir. No need to consider. Sir, I think you people got clarity, sir. How to remember so many sorting algorithms? Don't worry. That's why you joined into this data structures and algorithms batch. Okay, I will explain. Sir, I request everyone to please confirm. Is the linear time and quadratic time, how you are going to get? Is it clear for you people? Please confirm.
Yes, sir.
Right. Sir, the people who have not registered yet for this course, just I have shared the payment details in our chat window. You can you can register as early as possible. Okay. Maybe we are going to change the link from Monday. Okay. So I request everyone, from Monday we will have regular classes. So till that, so those who want to get registered for this, better to register. Okay. Right. Sir, do you want to see complexity for login? Can you please confirm, anyone? Do you want to see complexity for login? Yes, please confirm, so that we will cover one more example.
Yes, sir.
Right. Sir, there is a small change in this algorithm. Listen carefully. How to calculate? Sir, I will do half iteration. Sir, previously we have done full iterations, right? Full iterations. Now I am going to take half iterations. Half iterations. Sir, how to reduce that number of iterations? Here I am going to take I is equal to, in the place of I is equal to I plus 1, better I will take I is equal to n. So I greater than, okay, I greater than 0. So I is equal to I double slash 2, half of the times. So I am going to do. Now we will see how much time it is going to take first of all. Sir, how much time have you observed? 7 times the loop is run. How many times the loop is running? 7 times. Sir, how it is 7 times? Have you observed? Sir, here count is equal to 0. First time I is equal to 100. Sir, is it greater than 0? Yes. Next time your I value will become 50. Sir, is it greater than 0? Yes. Sir, count will become 1. Sir, next, I think for this count is 1. For this count will become 2. Next half, 25. Is it greater than 0? Yes. Count will become 3. Sir, next again 12. Is it greater than 0? Yes. Count will become 4. Sir, 6. Is it greater than 0? Yes. Count will become 5. Sir, 3. Is it greater than 0? Yes. Count will become 6. Sir, 1. Is it greater than 0? Yes. Count will become 7. Sir, 0. Is it greater than 0? No. Have you observed? Assume I have 100 numbers are there in the list. I want to search for an element. Sir, we are not going to do this searching in this total. We will select either first half or second half. Again, in this we will divide half. Again, we will divide in this half. Like that we are going to see. Sir, have you observed? Binary search. How much time binary search is going to take? Big O of log n time. Have you observed? This is nothing but what we have. Sir, how you are telling log n? Just I have a doubt here. Let me check. Sir, log 100 value. I want to check log 100 value. Okay. So logarithmic values. Okay. Logarithm table. Okay, sir, let us see somewhere logarithm value calculator. Okay, let us see. Let us see. Sir, log 100, it is already there. Sir, what is the result that we are getting? 4 point. I think it is base E. Let me take base 10 or base 2. It will be there. Sir, base 2 is nothing but 2. Base 2, let us calculate. Something like 6 point something we are getting. Approximately it is equal to 7. Sir, have you observed how this time got reduced? This is the way in this algorithm. I can say I can say the time complexity is nothing but how much, sir? Big O of log n. Like this we have. Sir, I think at least some idea you got about the complexity, sir. Sir, now we are not required to calculate by writing a big code. Directly by seeing the algorithm itself, you can tell how much time it is going to take. Can you please confirm clear up to this? Clear up to this? I request everyone to please confirm. Clear up to this?
Yes, sir.
Friends, please confirm.
Yeah, yes, sir.
Right. Sir, I will show some piece of codes for you people. You have to tell time complexity for that. Okay. Please try to put it on chart window. Sir, just don't write a big O of something like that. N log n or n square like that you type. Sir, can you please tell for this algorithm how much time it is going to take? Yes. How much time it is going to take? Not n by 2. Not n by 2. Okay, it will take big O of n, big O of n. Maybe internally some small things will be there that we will discuss later. Big O of n. Because, sir, I request you to please put your questions in the chat window because your network is not good. So we will see how internally it is going to evaluate. As of now, if you are seeing any loop, then it is going to work for n times. Similarly, here also it will work for n times. Okay. So here it will work for n times. Okay. This one is going to take linear time. This one is going to take linear time. Okay. Maybe internally how this reduce function is written based on that. Okay. Like that we have, sir. Okay. Anyway, we will see in detail about this. Okay. Now, sir, next coming to our next programs. Here I want to take example number 6. Sir, what is this program here is, I want to write a Python program to find a maximum of 3 numbers. Okay, maximum of 3 numbers. Next program to find minimum of 3 numbers. Sir, next one, I want to write a program to find maximum of 4 numbers. Okay, so next I need to write a program for minimum of 4 numbers. Okay, similarly, maximum of 5 numbers. Similarly, minimum of 5 numbers. And the next one, find the difference between maximum and minimum of 5 numbers. Like these algorithms we have to see, sir. Of course, in the upcoming classes, we will talk about this. Okay, in the upcoming classes, we are going to discuss in detail about this. Still, we have some programs, sir, like a factorial calculation and even string-based applications. Few applications. Around how many applications we are going to discuss? I told in the beginning itself, around 20 to 30 programs we will purely concentrate on this sample algorithm so that you people will get a clarity how you can able to solve. Okay. Today you want to discuss about while loop and for loop. No, Geeta, I will discuss maybe tomorrow. Okay. Because in this we are not started with the loops, right? Maybe I will take while loop and for loop. Definitely I will show you how it is going to work. Sir, clear up to this? Please confirm. Right. Anyway, remaining things we will continue from tomorrow, sir. the people who registered for this course, you people are going to get access for running notes today. Remaining people, you can start making the payment by today. Okay. So those who have not paid the fee, can you please confirm? Those who are still not paid the fee, can you please confirm when you are going to get registered for this class?
Sir, I will register tomorrow.
Right.
I can register tomorrow
Sir,
Right.
tomorrow.
because I have it, so it will take some time to transfer the money.
Yeah, right. Good, good. So
Sir,
I
I
request
have a
everyone.
little.
Yeah, please, sir.
Oh, sir. So we teach everything in detail, like you have taught
Sir, your
rotations
voice
and
is
linked
breaking, sir.
list.
Sir,
So
sir, sir, your voice is
is
breaking.
it coming well? Yes, sir. It is coming well now.
Now it is okay, sir.
Yes, so I am asking, sir, will you teach everything in detail, like link list and Waco notations, like time complexity, space
Yes,
complexity,
we will see in detail, sir.
from
But
from
time
basic.
complexity, yeah, time complexity, all these things at the top level only we are going to discuss because it is related to mathematics.
Okay,
Okay,
sir.
I am
Okay,
not
sir.
going in detail, but for I will tell how to calculate time and space complexities. Multiple examples, minimum 20 algorithms I will explain on that.
Yes, sir,
But
because
rest of the things, yeah,
Yes,
linked
sir.
you asked, right? In
Yes, sir.
depth we are going to see in the linked list.
Yes, sir,
Okay,
because I
what are
didn't
the
get, I didn't get much in this session, so that's why I'm asking.
yeah, sure, sir, definitely we are
Yes,
going to
yes, sir.
see in detail.
Okay, sir. Thank you, sir.
So yeah, so here my intention is to I have to learn more. So that is the reason. Parallelly, whatever I am preparing, I will deliver for you people. Here advantages, two advantages are there for me. One is nothing but I am getting salary. Second one is I am learning the new concepts. That's all. Yeah, Agarwal, you will get confirmation by Monday. Monday, you are going to receive new link, sir. Monday evening, we are going to share new links for everyone. And those who have registered tomorrow evening, just remind me, I will give running notes access. So in your Google Drive, if you have got running notes means, then you are a registered student. Okay. Tomorrow I will give access. DSA is the next level of C language, Rame Krishna. It is not related to language, madam. It is independent. Whatever practice, whatever concepts I am explaining, same thing we can do in Java also. Same thing we can do in C language also. Same thing we can do in C++ also. Data structures is required everywhere. It is independent of programming languages. Okay. Right. Okay, sir. Fine. Thank you. See you tomorrow. Good night.
Thank you, sir.